Welcome to Power of Numbers R tutorial. My name is Shumaila Bhatti and I'll be guiding you through this tutorial. So, let me first introduce you to the interface if you haven't had the chance to look at the book yet. This is your user interface. On this side you have the R script. In the bottom left you have the console where your code will be run. On the top right, you have the place where you will see your functions and your dataset. On the bottom right, you will have your files, access to your files, your packages, help features, and other content that you might have access to. On the top, you have options on creating new R script. As you load the R tutorial that is provided to you with this book, I would encourage you to also create a new R script so you are used to saving your own versions and creating your own content. R scripts are basically a place where you store your code, and the console is where you run the code. So, I would encourage you to start your R scripts with your name, date, objective, and pseudocode. Pseudocode is basically code which tells you what the code is supposed to do. Our first step would be to set the working directory. The working directory essentially is basically telling R that this is the folder from where we will be accessing this content or this file or this data from. And this is also the place where R will be outputting all of your information to. For example, if you write a CSV file or if you want to output a table or a plot, this would be the location that R will send it out to. So to have a proper database management, you want to have one folder which you want to set as a working directory. To do this, you have several options. You can go to your session, set working directory, and choose a directory, or go to your respective keyboard shortcut, Ctrl-Shift-H, and navigate to your folder. After you navigate to your folder, you select that folder, and then you open it. You can copy-paste this address into your R script, especially if you're planning on reusing that script or this code in the future. Another important part about R is that it has packages built in. In your R tutorial, you have an option and code given if you have not installed tidyverse or Haven. These are the two packages that we currently need access to. So if you haven't installed the packages, you can run this code. You only need to install these packages once, so you don't have to do it again every single time you run your code or you run your session. You can also go to this packages tab here, click install R packages, and then type in the package name and click install. It should automatically install to the local rwin library folder on your computer, and make sure that install dependencies is checked. We are, however, not done yet. Just because you have installed the package does not mean that the package is ready to use. You have to load the package, and to do that, you have a separate line of code called library. From library, you will load tidyverse and Haven. So all you need to do is run these two lines of code. And you can run this code by either clicking run here or using the keyboard shortcut Control Enter. Now let's load the data. You can copy paste this part of the function that loads the data. We basically are telling this to save our data set as PONE D2 DTA. We're going to read an SAV file, which is labeled this in your folders. Make sure that you have this file in your folders before you load it. You can do this by navigating to your files portion and make sure that you go to the working directory and that you have the SAV file up here. Once you have the data loaded, you can view the data by clicking on it or by using this code, view data. You can scroll through the data up and down, and you can also use these arrows to navigate through the variables, which are 112, also known as columns, or down, which is rows for 413 observations. We can look at variable information also through using functions such as glimpse that gives us information of all the variables and what the responses are for those, but it doesn't give us all the responses, by the way. We can use the head function to get just the top 6 responses of the full data set. We can also get just the column names if we want to just have the accurate name of the columns. Remember, R is case sensitive, so you cannot use small capital letters or small letters just as you see fit. In this session, we're going to try to recode one of the variables here, which is politics. But first, let's look at the political orientation variable. Using the function table, the dataset name, $, and then the column name or the variable name, which is right here, we can call and ask for how many respondents are in each of the discrete categories. If you go to your respective code books and your book, it will show you how 1, 2, and 3 are labeled as from extremely conservative to extremely liberal. So let's recode these variables using a function feature. This function basically says when we provided a column, it goes through each of the rows X, and it determines whether that X or that row has 1, 2, or 3. And if it has a 1, 2, or 3, it will give it a 1. If it has a 4, it will give it a 2. If it has a 5, 6, or a 7, it will give it a 3. We will save this function as political or pol_encode. To run this function, we will create a new column called political recode in the dataset. And to do this, we will use the same $. And to apply the function, we will use the sapply to our political code column and apply that function. So let's run the function here. And we can see the function has popped up into our environment. And then when we run this code, we see no errors. That means the code has run. And now we can type table $, and it shows us 1, 2, and 3, the variables that we wanted to code. But we're not done here because we want to have labels to these codes. To do that, we will create labels for each of these codes known as political labels. However, these labels are just values and have not been assigned as of yet. So even if we press the page up button, we have not yet assigned them these values. Using the label SPSS function, we will use the political labels function to label the orientations of the categories that we have selected. And we will use the same variable or column name, exactly the same column name, and we will overwrite the labels as 1, 2, and 3. Now, if you go up to your previous code, it should be able to give you the labels. After you run the label SPSS, make sure you convert them to factor so that you are able to read these codes. If you go to your dataset and you go to politics, sorry, political recode, it should be at the very end. You should be able to see the recoded values. Another part of this class session is for us to run a reliability analysis. When we have several variables that measure the same construct, we want to see how well do they measure the construct. To do that, we want to see if the variables are correlated with each other and how significantly are those correlated. To do that, we calculate a Cronbach's alpha. To calculate the Cronbach's alpha, we need another library package, which is called psych. If you haven't installed it, I would encourage you to go to packages and install it, or use the code in the R tutorials provided. In this portion, I will also introduce you to another code which is called piping. As you can see here and here, piping essentially just makes you go through step by step and drills through different parts of your data. So here it is saying that select these columns from this data and apply this alpha function to these selected columns from this data. We also are telling it to derive the alpha from psych package, because previously from the tidyverse package there's another alpha which is masked. So we want to ask it specifically to calculate the alpha using the psych package. Therefore we use these 2 dots here. 2 colons, my apologies. When we run the code, we find the raw alpha, which should be above 0.9, which is great. This also gives us the mean and the standard deviation. It also shows us what happens if an item is dropped. If we drop this item, our reliability is convex alpha is still going to be 0.93. However, how do we calculate the mean average of all of these rows across all of these variables? To do that, we use the same portion of this function where we ask to go through this data, select these columns just like we did up here, and calculate the row means. We will add one more thing here though. We will ask it to remove anything or do not consider anything that has an NA in it. We will create a new column called mRNI_AF index. In our previous data set, as you can see, it highlights all of the data using the $sign. Make sure the $sign's there, otherwise it's not going to create a new column for you. So in the new column, it's going to create row means out of all of these selected columns. So when we run this, we have a new variable here, which is this one. So if we type head and explore this, we will see we have row means for the first 6 variables, first 6 rows, my apologies. You can save your R script in your folder. And continue working from there. I'll see you in the next tutorial.